Okay, so now just give me your attention up here. We have the section. Now, if you don't want to have your iPad open to the page, that is perfectly fine. I really just want you to listen to me. Also, there's going to be some times where it's just easy. All right, I'm not asking you to write the problem down for the most part. All right, but now, listen, Max, you have to focus on what I'm saying because, again, today is the introduction. This is new material. It's not a review of anything. All right, so I need your attention. And not only that is, listen carefully, the slope is a big part of your SAT and your ACT, your standardized test. So again, very, very important. All right, very important. All right. Don't worry about the page right now. Okay. All right. Now, today we're going to talk about slope. And last year I asked you to graph lines, and you were able to graph lines by plotting points. This year we're going to graph lines a little bit differently and a little quicker. And I'm just telling you, for those of you guys who daydream every once in a while, and you talk to your friends for 30 seconds, while you're talking, you're getting lost. Everything that I'm saying right now is super important. So please concentrate on what I'm saying. All right, most people aren't sure exactly what they mean when you talk about skiing on the slopes of a mountain. All right, but the slope just describes how steep a line is. All right, so the bigger the slope, all right, the steeper the mountain. All right, and they also had to start somewhere. All right, so look right up here. This pencil is kind of like the line. All right, this is where it starts out. That slope right there is equal to what? Take a guess. 0. That is exactly correct. Now, that's what I'm saying. You have to listen the whole time. And that's why I was walking over there towards you, trying to get your attention. You're already behind because you weren't listening. That goes for everybody. Your slope right here is 0. Now, it's no longer 0. It's getting what? Steeper. It's getting steeper. So the slope is increasing. All right? Then all of a sudden right here, that's as steep as it can get. And it's so steep that we say it doesn't have any slope at all. And I'll explain mathematically why it doesn't have any slope at all. But I tell kids you can easily remember that because you can't ski down that mountain. All right? It's called free fall. Right? This right here is where we start. The slope here is positive. The reason why I know that slope is positive because remember you always read numbers from left to right. So I always tell kids if you read numbers from left to right, you're going up the mountain. Do I agree? So that's why the slope is positive. If you get to a point in this direction, now the slope is what? Negative because you're walking what? Down the mountain. Now some kids say, how do I know if I'm going up or down the mountain? You have to understand that you're reading numbers from what? Left to right. If you know that, it's obvious. That slope is what? Positive. This slope is what? 0. This slope is? And this slope is? Undefined, you say, or no slope. All right? That's how important. Now, how do I know the difference between two lines? Well, the difference between two lines has to do with the what? Slopes are different. So if the slopes are different, you create what? Different lines. Everybody with me on that? All right? So the most important thing for graphing a line is understanding what slope is. All right? Now, slope is basically defined as a rate of change. All right? Slope is defined as a rate of change. All right? Now, generally, when you're drawing a line, there is a y-axis. Come on. Stay with me. Everybody's got to listen. It's the important part. There's a y-axis, and there is a what? There is an x-axis. The y would give some type of, comparison, and then the x would also be some type of comparison, right? For example, you could say time, and you could say money, all right? So if your y-axis is money, and your x-axis is time, you're going to say the slope has to deal with the change in y over the change in x. And the y would be the change in money over change in time. All right, is everybody hearing me on that? All right, it's a huge part of the SATs and all standardized tests. You can put that in the garbage. All right. Now, again, today's lesson, we're going to go ahead and we're going to, now I'm going to drop down. We're not going to start out with problem number 1, but I'm going to drop down. I'm going to try to write a few things out, something that I think is important for you to write out to make sure that you understand exactly what I'm talking about. And then once I explain this, then we'll be able to quickly get back to the problems. And the problems are really not that hard. It's just that this lesson is super important. All right? It's a very easy lesson. All right? But again, very important. All right? So the first thing we're going to do now is we are going to talk about the slope. So I'm going to scroll down. All right? And then we're going to talk about slope. All right? So I want everybody to write down slope. And we're going to talk about slope. A rate of change. All right? Slope is considered a rate of change. Now, for whatever reason, I'm not sure why, but they gave slope the variable m. All right? And because it's a rate of change, all right, it's going to be considered delta y over delta x. Now in science, what does delta mean? Change. Very good. It means change. All right? Now how do you find the change in something? What do? You subtract. Thank you very much. You're going to subtract. So the formula is y2 minus y1 over x2 minus x1. Now the problem with slope is that many people put the change in x over change in y because when you plot points, you go what first? You go x and then you go y, right? But the slope, you have to remember, is the what? Change in y over the change in x. Now what exactly is y2 and y1? All right, and x2 and x1? Well, most of the time you're giving different points. So the subscript is just saying that they are what? Completely different points. All right? You can't find the slope given only 1 point. You cannot find the slope given 1 point. You need how many points? 2. All right? Now, in a couple years, when you're sitting in your calculus class, I will show you how you can take a slope given 1 point. But right now, the slope is always an average rate of change. An average rate of change. And let me just give you an example of what that means. All right? So let's say it took you 2 hours to get from your house to school, and it was 50 miles. All right? What was your average rate that you traveled? If it took you 2 hours to go 50 miles, then you averaged what?
25.
That's exactly right. Your average is 25 miles per hour. Does that mean you were always going 25 miles per hour? No, you could have been going 50. You could have been going 100. But at one point, it averaged out to what? 25 miles per hour. All right? So that's what we say when we're talking about in a word problem. When somebody says rate of change, you'll know that they're talking about what? They're talking about slope. All right? Now, again, slope is defined as y2 minus y1. Now, notice what we're starting at. The y values. Right? We're not graphing the x's first. Now, does it matter the order in which you do the subtraction? And the answer would be what? No, it doesn't matter. Now, again, I'll show you that in a particular problem, but right now I want you to remember the 2 points are any 2 points. All right, and it doesn't matter if you're going from point A to point B or from point B to point A, the slope is always going to be the same. All right? Now, let's put this into some context now. Let's go back up to the original problem here, and we'll talk about it. All right, question number 1 says, find the rate of change. All right, so if we want to write the rate of change, I want everybody to write this down. M equals delta y over delta x. Now, there are 3 ways, all right, that you're going to be able to find the slope. One is from a graph, another is from a table, and another is from 2 points. Right now, we're trying to find the slope given a graph. All right? So basically what you have to do is you have to find the 2 points that you want to discuss. And I found these 2 points right here. Does everybody see that? Now again, just all you have to do is really pay attention. All right? Now, the change in y represents this. I went from here to here. Does everybody see that? This is referred to as delta y. From here to here represents what? That represents delta x. So, somebody tell me what delta y is. How much should I go up? 4. Thank you very much. I went up 4. And how many did I go to the right? 3. So my slope is simply what? 4 over 3. That's how simple it is.
That's all you do.
That's it. 4 over 3. Super easy. Now, some of you might be saying, well, what if I wanted to go from this point here? Now, please watch. Here's the important part. Here, and then I went in this direction here. Everybody see that? It's going to be the same thing. However, I'm going down. And down is what? Negative. So this would be what? -4. And then the other direction would be what? -3, because you're going to the what? You're going to the left. So going to the left is negative. Is everybody with me on that? Sorry, I don't know why the signal keeps dropping. All right. So does everybody agree it would be the same as -4 over -3, which still stays as what? 4 over 3. Everybody good with that? All right, very, very important. Yes.
Oh, so you can just pick any 2 points.
That's exactly right. But I've selected the 2 points that were given. Right? Now, he says a good point. What if I selected this point and I went from here to here? What's the slope going to be? Someone tell me who was listening. What's the slope? Nope. What's the slope? Somebody else. What is it?
The slope would be 2.
Nope. Somebody else. Of course, 4 over 3. Now watch this. I'm going to show you something else now, please. Listen carefully. What if I went from here to here? What's that slope? 4 over 3. What if I went from here to here?
4 over 3.
4 over 3. It doesn't matter. The slope is always going to be what? 4 over 3. Because hopefully you can understand what I'm saying. It might be 8 over 6, right? And 8 over 6 is still what? 4 over 3. It might be what? 0.4 over 0.3, which is still what? 4 over 3. It doesn't matter what 2 numbers I select, the rate of change for a line is always the same. The rate of change of a line is always the same. It doesn't matter what 2 points you pick. Is everybody good on that? All right. So now, normally I would say skip number 2 because that's going to be for tomorrow, but it's a table. All right, it's a table. So I want to show you. First we did a graph, or we did a line. Now we're going to do a table. All right. So let's figure out what delta y is. And let's figure out what delta x is. Now delta y is the change on the y-axis, correct? So you get to pick any 2 points you want. So what I want to do is I'm going to pick easy points for me. I'm going to select this one, and I'm going to select this one. Is everybody with me? And then I'm going to find it. I went from 10, pay attention now. I went from 10 to 2. So what was that change? 8. And then I went from 7 to 5. What's that change? 2. So what's 8 over 2? 4 over 1, or just 4. So we can say the slope of that line is what? 4. Is that good? Now let's just say if I'm accurate. Let's now pick here's the 2 points that I want you to pick this time. I want you to pick this one and this one, the top and the very bottom. So somebody who's been paying attention, tell me what's delta y. Delta y is not 20.
4.
Well, the slope is eventually going to be 4. You're right. But yes, it would be 32. Thank you very much. Now the question is, how did I get 32? Well, 32 is 26 minus negative 6. Did everybody see that now, right? So I went 26 minus negative 6 over 11 minus 3. And that is, thank you, 8. And what's 32 divided by 8? We already knew what the answer was, 4. So I'm trying to show you now, does it matter what 2 points? No, but of course we always try to pick the easy ones. Agreed? Very simple. All right, so now we've calculated the slope from a graph. We calculated a slope from a table. And now we're going to calculate a slope from a point. So I'm going to jump down to number 7 real quick. All right? And those are all the 3 different ways. And then if you want to give yourself some room, give yourself room to go back into the odds. But I'm going to jump down to show you. All right? So I did a graph, I did a table, and now I'm going to do a point. In reality, is a point any different than the table? No. It's just they tell you what 2 points to use. All right? So here we go for number 7. M equals 1 minus 3 over negative 2 minus negative 4. Now, do I ever really want you to write a minus and negative? No. We already automatically know that a minus and negative just means what? Positive. Is everybody with me on this? So we're never going to do a double negative. Does everybody agree with that? So now, what is 1 minus 3? And then what's 4 or negative 2 plus 4? So the slope is negative 1. All right, does everybody agree? Very easy, very easy. All right, but again, make sure you see that. All right, make sure you see that formula and you use the formula properly. All right, now just to make sure you guys are hearing me, I went 1 minus 3 and then I went negative 2 plus 4. Would it work if I went the other direction? I'm going this direction this time. What's 3 minus 1 over negative 4 plus 2? 2 over negative 2 is still what? Negative 1. Again, I just try to demonstrate to you, does it matter the order in which you do the subtraction? It makes no difference. All right? Slope is very easy. All right, very easy. All right, now from there, I want to just go back now. And I want to take a look at number 3. We'll take a look at number 3. Now, of course, number 3 is like an SAT problem, which is the absolute most important problem. All right, because now you've got to apply what you kind of understand. Let's see if it makes any sense. So if I look at number 3A, it says, find the rate of change. Now, rate of change. You should highlight rate of change and say rate of change is just a fancy word for what? Slope. Thank you. Rate of change means slope. So we're finding the slope of the prices from 2006 to 2008. So I'm going to find where 2006 and 2008 is on my graph. So here we go. Here is 2006, and here is 2008. Does everybody agree with that? So I need someone to take out their handy-dandy calculator because we are going to do delta y over delta x. Right now I need to figure out what delta y is. Did you figure that out yet? Jack, you got it? Tell me what you got.
Is it 22?
No. Change in y. So listen, I'm highlighting y. Do you agree that's a y value? And this is a y value.
Oh.
I don't know what you're doing. So 2873 minus 2666. Someone tell me what that is. You're daydreaming all day. All day.
Me? Oh, I know.
Somebody tell me what that is. What is it, Ben?
I got 2.07.
2.07. Is everybody okay with that? 2.07. Now look, again, this is where you don't take someone else's word. All right? How did I get 2.07, Ben? That's exactly right. You subtracted 2873 from 2666. Now, who can tell me what change in x is? What's change in x? Don't shrug your shoulders. 2, because we went from what? 6 to what? 8, which is how many? 2. So there we have it. So delta x is 2. All right? So the slope is equal to 1.035. Anybody have any objections to that? What?
Did you do that in your head?
It's not that hard. What's half of 7? There it is. You see what I'm saying, right? So again, never, if you want to know how I'm doing it in my head, just ask me. And it's simple, simple, simple. All right, all I did was took half of 2, which is what? 1, and half of 7 cents. 3.5 cents. Very easy to do. All right. Anybody have any questions? Anybody have any questions? So that would be the slope at that year. Anybody have any issues with that? Very easy. All right. So now let's look at B. Without calculating, find a 2-year period that had a greater rate of change in 2006 to 2008. Come on, what's the greater slope? Good for you. Tell me.
98.
Of course, because it's steeper. Come on, everybody needs to look at that and say, yeah, that was kind of obvious, right?
Are there more than
No. Well, I'm not 100% sure. So it's close. These two slopes are kind of close. You could have said, actually, that is greater.
Yeah.
You're right. So 2004 to 2006 has a greater slope. The absolute greatest slope, though, was from 98 to 2000. Agreed? All right, so that's what they're asking me. All right, now, the important part for my thinkers. Listen, come on now. This is the SAT question. Right here, SAT question. Between which years would you guess a new stadium was built? All right, now, first of all, I had no idea. None. I didn't even know what they were talking about because I never read the graph. What is the graph talking about? This is Houston baseball team, correct? So here was the price of each ticket, and here was the year. Your job is to say, when do you think the new stadium was built? Will?
Probably. Like at 2000, like 1995.
What are you thinking? Good for you.
2002.
2002.
Oh, I see.
What do you think?
2000.
In 2000. What are you thinking? 1998. What are you thinking?
Yeah, 1998.
What are you thinking? Now, if I said,
98.
because do you agree that a stadium wouldn't be built like overnight, right? So it's going to take probably a couple of years, right? So now think about it again. What years?
1996.
96 to 98. Anybody else? Good for you. Tell me what.
98 to 2000.
Now explain why, please.
Because in 98, like, it's 11.88, and all of a sudden it increases like a lot
Why would they do that? Shh.
because it's like nicer than where they used to play before, so it would be a lot more money.
It's 100% correct. That's why I just get fussy. If you just pay attention the whole time, things could be a lot different. All right, that's 100% correct. Listen, the new stadium was probably built. I'm not saying that has to be true because we don't know. We're just saying if you build something new, the ticket price is probably going to go what? Because you have to help pay for the what? You have to pay for the stadium, right? Does everybody agree with what I'm saying now? You'd have to help pay for the stadium. So I believe, I would say, from 98 to 2000, the price of the tickets would go up, right? Because that's going to help cover the cost of building the stadium. Yes.
Wait, but wouldn't 96 to 98 be like, Like when the stadium was built, because after it. Oh wait, never mind.
But listen, I'm not saying I'm right. I don't. I'm just saying, my theory that would justify why there was a big increase in the price of the
What if
tickets.
they were building it? Like when they have debt, so then when they want it.
Well, they could listen to me. So, in my opinion, here's what happened: is like the Devil Rays or the Rays, whatever you call them, they're going to build a new stadium, right? So they're not raising the price right now. They're going to build it, and then people are going to say how nice it is, and they're going to do what? Raise the rates. You with me on that? Because they want people kind of, somebody's got to pay for it, right? And it's expensive to build a stadium, right? It's like $100 million or something. So somebody's got to pay for it, right? So again, there's lots of different things on here. That's why I'm saying just try to get into your head. I'm not necessarily saying I'm right and you're wrong. I'm just saying I'm theorizing that it would have to be the increase here because the stadium was being built. And plus, if something's nicer, more people might want to go. All right?
Well, what if 96 to 98, they would, that's when the stadium was being built, but then the ticket price would raise?
Well, you could say that. You could say that because they're still playing in the old stadium. So it might, but you know what I'm saying? I don't know. It's not really that big. All right? So now that we have that, all right, what I want to do now is I want to take a look at question number 5. All right? Now, if it's linear or if it makes a line, the slope will always be what? The slope will always be the same. Do everybody agree? So now I want to look at number 5. Please pay attention now. From here to here, I'm adding what? 4. From here to here, I'm adding, from here to here to here. So it looks good so far. From here to here, I'm adding, or I'm
Subtracting 2.
from here and from here. So is it the same?
Yes.
It is not the same. It's not linear. Because if it's linear, the change will always be what? The same. You with me?
Oh, I see.
Right? So here they kind of tricked you here and said from 3 to 0 was what? 3. Does everybody agree? So again, I don't want that. All right, I want it to be always to be 2. If it was going to be linear, the 0 would have to be a what? A 1. And then the negative 2 would have to be a, thank you very much. That is 100% correct. So now we just fixed it so it would be linear. All right, because the change is the same. What?
Can it also be different because like 8 plus 7?
No, that has nothing to do with it, believe it or not. Yeah, that's a good thought, though. All right, it's a very good thought. But no, the change is from what? The difference between the 2 points. You with me on this? All right. Now, we already did number 7, so let's take a look at number 9. All right. What I'm going to do is I'm going to do this. I'm going to drop 9 through 13 down. All right, here we go, guys. All right, so here we go with number 9. I want to find the slope. Slope equals, come on now. Now I want everybody to write down m equals y2 minus y1 over x2 minus x1. Write the formula. The reason why I'm asking you to write the formula is so you'll remember the formula. All right, what is y2 minus y1? Somebody tell me. Okay, but how did you get that? 3 what? Come on.
Oh.
3 minus 10.
Yeah.
Right?
Yeah.
Over what?
Over
Beautiful. Is everybody happy with that? Now look, please speak up. Girls in the front. Everything good? Any questions with that? All right. So what's 3 minus 10? And then over, which is the same as 7 over 9. All right. Anybody have any problems? All right, so here we go, please. Help me out with number 11. Again, m equals y2 minus y1 over x2 minus x1. Yes. No, I'm on 11. I'm on 11. Somebody help me. Alex? What am I doing? Looking at these points right here, buddy. Come on now, you can do this. Exactly. So far, so good. 2 minus 2 over. You're awesome, buddy. That's very good. Negative 6 minus 5. What's 2 minus 2? Over. Which automatically means it's just what? 0 divided by anything is 0. Is everybody hearing me? Which means it's what type of line? Horizontal. If 0 is in the denominator, it's undefined. Hear me out. You can't divide by 0. All right, you cannot divide by 0. So if my answer was 7 over 0, it would be what? Undefined, and we say it's a vertical line. If the slope is 0, it's a horizontal line. Everybody good? All right, one last thing now, the hard one. Everybody take a look at 13, please. 13 is the hard one. All right, now,